Okay, we're gonna set up the drive plate and torque converter. This is the first step of doing that. We can take material away at home. We can't add material. So we've got to make it for the smallest torque converter nub that we've seen out there, so that it can work for everybody. And unfortunately, it's kind of annoying sometimes because you're gonna have to remove material. But it's fairly easy to do. And you don't have to worry too much about doing it. You'll do it by hand or with a drill. You don't have to worry about affecting the balance on the drive plate or anything too much, because it's so little material on the very inside of the rotation. So what I've got here is just a little sanding cartridge roll type thing on a drill that just about fits in there. What you can do is place the torque converter onto the drive plate and see how it sits, see if it fits on there and drops on nice and even. That's what we're looking for. It just sits all on its own without forcing it together. Basically what we want to do is make sure that the most important thing when we're aligning this is that there's no wobble, meaning if you're looking from the top like this or the side, there's no play this way, basically run out. And so that's what we'll make sure that's sitting nice and flat on here and not being pulled up and then grabbed and tilted one way by one of the fasteners. So this one needs a little bit more, so we'll go ahead and you can see, once you give it a spin, you'll see where the mark is, and you can go ahead and then remove some. Let's do this. It's a little better, but there's still, if I place it on there, I can see there's gaps. If I look from the side like this, there's gaps, and you can hear it. We're not there yet. So I'll just go ahead and I'll make another mark. Hold it, spin it. Let's get. All right, so after the maybe 4th or 5th time, I did it enough where now there's no gap here. If I put it down on the real flat surface, there's no wobble. It's just real tight. It's even when it's all the way on, it's a little bit tricky for me to spin, but that's how I can loosen it to get it off. I didn't have to take off much more than the last shot in the video there, but now it's real good. So now what we need to do is we need to check runouts. Okay, so now we're set up with just the block again. We haven't started doing the SKA or anything yet. We can do this this will be the first step, something that has to get done. I like to do it before we do the SKA because I use the magnetic base that just mounts easily without the adapter plate in the way. There's very few things in this kit that have to be done actually in exact order. One of them for the SKA is the crank position sensor cup. So we couldn't now just put this on and then torque all these down and call it a day. So that's one thing to note. We will be pulling this back off again. So we get the guy on there. Make sure both surfaces are nice and clean. We don't want to clamp dirt. This is important. Line up the index holes. The bolt pattern appears to be symmetrical. It is not. Okay, so we got the drive plate by itself mounted. And the next thing we'll do is we're going to check runout of the plate itself to give us the baseline. Okay, so here we are set up with the dial indicator ready to rock. You can't get perfectly inside the bore. Obviously, getting it exactly perpendicular to the crankshaft would be great. This is close enough. The angle is quite low. You'll know if how good or bad you're out. And this is gonna measure the runout or basically eccentricity off the crank center line that we see. So I've got everything in position. It's held to the block with a magnet. I don't know how well you'll be able to see this. Make sure we zero the gauge. There it is, that's zeroed. And I've marked over here, I've just marked one of the holes so I know I just have to come all the way around 360 so we can see the whole thing. And then I'll just start spinning it. And you can see we're very good right now. We're 180 out and it hasn't left zero. As is the case with all these parts. They really should be well less than 2 thou run out at the bore. Yep. And this is not even remotely close to 1 thou. This is probably about 5-10 thou if we were to measure it even more accurately. And that's what we want to see. So the next step now will be attaching the torque converter to this again and finding of which of the 3 possible positions gives us the best runout reading on the end of the torque converter. The torque converter will have a lot more slop than the drive plate. Okay, so I've got the torque converter now in with the torque converter fasteners holding it snugly to the plate. I already bench prepped it, so it should sit nicely wherever I put it. Now let's figure out which is going to be the best location. So we'll do a similar setup to where we did before. We're going to have to obviously reset the All right, so now that's more or less zeroed out. Again, we want to get the kind of the top or the bottom as best we can of this edge. You can go on the outside edge or the inside edge. I think the inside edge was a little easier, made a little more sense for positioning on this one. And I should have enough clearance to go ahead and do this. And I'll again, I'm just going to mark a dot on the outside so I know which one it is that I need to come back to. To make sure you're not actually scrubbing anything on the micrometer. So there we go. We've already started to go. We're at 1, 2, 3 thou. That's out to about 5 and then back. So and then we went right to about there. So it was about 5 on one side and 4 on the other. So we've got about 9 thou. And now 9 thou is under spec. Anything less than 10, we're doing all right. Over 10, you definitely want to, then you start messing with seals. So what we'll do now is we'll undo the fasteners and I'm going to reclock it to one of the other 2 positions. I can leave just about everything else in place so we're not messing with it too bad. And I'll re-zero and then we'll do it again in a second. All right, so I got this all set up in the second now position and we'll see if this one's any better. So we'll do the same thing. I've got, I know which position I need to go all the way around on, and then we'll watch the gauge here. So that's out to 4, and it's maxed out at 4 on that side. Okay, here we come. Let's go in the other direction now a bit. also 4. So 8 thou. That's a little better than the 9 you measured that time. So the second position is already better than the first one. So I'd pick the second one over the first one. Let's try the last position and see which one's best. All right, so here we are set up in the third position now. I'll go ahead and test this and we'll take a look. That's 5 to 5.5. 5. So this is a little bit worse than the first one. So the second position is the winner. So what we'll do now is, since I marked everything, I'm going to undo the screws, clock it back to the second position, which is the best of the 3 tested, and then I'm going to paint marker the drive plate and the torque converter there. So we always want to match them up. When we do it in the van later, we'll be able to see through the inspection hole, which will be on this opposite side when we're putting them together, and we get those mated up so that we'll have the lowest runout. So some people are asking why you got to do this setup phase, because usually you should just be able to spin the torque converter once it's in place and bolt it up. And so that's actually a great question, and it was a design choice. So one thing you'll notice about this drive plate versus a typical flex plate is this drive plate will not flex. It's much thicker steel. One of the other things you'll notice about the stock drive plates is that many of them are cracked now, especially near these ears where the bolt's actually attached to. There's these hairline cracks, and they can actually crack all the way through, work hard, and then fail in the van. And of course, that's a showstopper on the road. This, yes, is a little more involved to get the setup right, but once you get it set up right, which you're doing anyway in the comfort of a shop, your chances of anything happening down the road, like those fractures turning into breaks, are nil. So the other common reason flex plates are used, especially in racing, is because at high horsepower levels and output levels, the torque converter will actually change shape and balloon a bit. That's one of the reasons why the end play is so important too, and that's mentioned in the install instructions. But that's really important, obviously, in high output applications in drag racing. In our application, however, the torque converter will not balloon, and therefore we do not need ever a flex plate. It doesn't have to be that way. The only thing it will allow is if you have a really shitty torque converter that was rebuilt with a crappy jig, which we've seen plenty of, that will cause problems. But that's more a problem with the torque converter. And the torque converter's runout being crap. As you saw, the drive plate itself the runout on the drive plate is almost 0. So this is all the torque converter runout.